Square root asks the question, what times itself is that number? So square root of 16, the positive square root of 16, what times itself is 16? So this is a perfect square. Notice it's one of the green boxes. So we look and see, okay, what times itself is 16? Well, 4 times itself is 16, so the positive square root of 4 is, the positive square root of 16 is 4. That's sometimes called the principal square root. Next one, the square root of 100. That's also a perfect square. What times itself is 100? Well, that's 10 times 10 is 100. So the positive square root of 100 is 10. And then on number 3, 121, the positive square root of 121 is 11. Now, the negative is already in front of that, so we're actually looking for the negative square root of 121. Well, negative 11 times negative 11 is also 121. So if you have the negative sign in front of a square root, just keep it in front when you take the square root. They're not always perfect square numbers. So when we look at 32, we want to think what can multiply to get 32 that is a perfect square. So you're thinking through, are any of these numbers in green, are any of those factors of the number 32? So if you can pick out the biggest one, it'll get you to the answer the quickest. So 16 times 2 gives us 32. And the perfect square factor of 16, the square root of 16 is 4. Number 5, 125, not a perfect square, but 25 is a factor of that. 25 times 5 is 125. Or one way to think about it is 5 quarters equals $1.25. Now the square root of 25 is 5, so that comes in front of the square root, and you still have the factor of 5 underneath the square root. Number 6, you've got square root of 200. It's not a perfect square factor, but 100 is a perfect square factor. 100 times 2 is 200. Square root of 100 is 10, so we have 10 square root 2. Number 7 is the square root of 10 closer to 3 or 4. So the square root of what number would give us 3? Well, the square root of 9. Square root of what number would give us 4? Well, the square root of 16. So now if we compare the 10 to the 9 and 16, 10 is definitely closer to 9. So we would say that square root of 10 is closer to 3. Number 8, what number can you take the square root of and get 5? Well, it's 25. What number can you take the square root of and get 6? That's 36. So 33 is closer to 36. So we would say that the square root of 33 is closer to 6. Sometimes you'll need to multiply. As long as it's the same index, which we hadn't talked about that, square root has an index of 2. It's the most common root that we use, so we don't write the 2 typically, but it is an index of 2. As long as it's the same index, when you multiply them together, you just multiply the number that's underneath the radical, underneath the square root. So 7 times 11 gives us 77. Now, when we think about perfect square factors of 77, we don't have any, so we are done. When you have numbers in front of the square root, they multiply like normal. 4 times 5 is 20. And then multiply the numbers underneath the square root. 2 times 3 is 6. 6 does not have any perfect square factors, so it won't simplify anymore. Here there's a couple ways to think about it. One way would be to try to simplify the square root of 72 first. And 4 times 18 is 72. 10 doesn't have any perfect square factors, so square root of 4 is 2, so the 2 is in front. Oh, actually, I could have gone bigger. If I would have thought of 36 times 2, that would be a little quicker. Change that, 36 times 2. Square root of 36 is 6. So we have 6 root 2 times square root 10. Multiply those together, we get 6 square root 20. Now we still need to look for perfect square factors now, and 4 is a factor of 20. So we'll rewrite that as 4 times 5. Square root of 4 is 2. So in front we have 6 times 2 times the square root of 5. So that's 12 square root of 5. Number 12, when you add or subtract radicals, you can combine them if they have the same number underneath the radical, and they have, of course, the same index. So 2 square roots of 7 plus 3 square roots of 7 is 5 square roots of 7. Very similar to 2x plus 3x will give us 5x. Kind of the same idea when you think about like radicals. Number 13, it works the same way for subtraction. We've got 10 roots of 3 minus 4 roots is 3, so that's 6 square roots of 3. Number 14, they're not like radicals, but these happen to both be perfect squares. Hundreds in our list, so the square root of 100 is 10. 49 is in our list, square root of 49 is 7. Subtract that, you get 3. 15, they're not like radicals, but we can get the square root of 20 to simplify some. So for 20, we have perfect square factor of 4. 4 times 5 is 20. Square root of 4 is 2, so we have 7 times 2 times the square root of 5. So that's 3 square roots of 5 plus 14 square roots of 5. Total of 17 square roots of 5. All right, here we've got fractions. On fractions, when we have a radical in the denominator, it's not simplified. We need to get rid of the radical in the denominator. So we're going to multiply the top and the bottom by root 3. And just watch what happens. So 6 times 1 is 6, root 5 times root 3 is root 15. In the denominator, square root 3 times square root 3 is square root 9, which is just 3. Now, we've got to look and see if these regular numbers will simplify. 6 divided by 3 gives us 2, so we have 2 square root 15. Number 7, to get rid of the square root of 5 in the denominator, we'll multiply the top and the bottom by square root 2. I may have said that wrong. To get rid of square root 2 in the denominator, multiply the top and the bottom by square root 2. We get 7 square root 6 over 5 times square root of 2 times 2. Square root of 4 is 2. So if we multiply that together, we get 7 root 6 over 10. The 7 and the 10 have no like factors, so it won't simplify any more than this. $18 on the top, we can simplify that. Square root of 121, that's 11. All right, in the denominator, we saw the square root of 72 already and saw that it was square root of 36 times 2. And the square root of 36 is 6. So we get 6 root 2 there. Now if we multiply those together, we have 11 over 4 times 6 is 24. Square root 3 times square root 2 is square root 6. To get rid of the square root in the numerator, in the denominator, we'll multiply the top and the bottom by root 6. So we have 11 root 6 over 24 times square root of 6 times square root of 6 is 6. So we've gotten rid of the square root, or the radical in the denominator. Now we'll multiply 24 times 6. And we get 144. 11 and 144 don't have any common factors, so we're done. As you work through these, you may see different ways of simplifying them. So your work may look different than someone else's, but it could still have the same correct answer. Hope you've enjoyed this video. Feel free to subscribe, and my website's there at the bottom.